Example 3, I stated use the difference quotient or centered interval. These are some new ones that I made up. I hadn't checked them yet, so I was just checking them. Honestly, we would probably give you a hint and tell you which method to use, right? Because some people are like, oh, it's just going to be way worse. If they're both about even, like it's like, oh, they're both about even, difficulty, we'll go, up to you which one. I would probably on this one tell you that I would recommend the centered interval. It's a little bit faster to calculate. The difference quotient will work too, but probably a centered interval, and this one will be a little faster. So I would maybe give you a hint and say centered interval might be your choice. Both methods will work. I was trying it with the other class, and then here we were trying both. We did H1, H2. It just seemed like a bit more calculation, so you should work both ways. And then I did the centered interval. So we kind of went, you know what, centered interval will be my choice. Honestly, on a quiz and stuff, we would probably
just one more clarification. If you are choosing to participate in the Terry Fox walk, this is by class. So if your class is attending, then you will proceed with your class.
Yeah.
Again, it is voluntary. However, if your class is participating, you will proceed with your class students. And it doesn't have to be a very long walk. It can be just one lap around the track. Okay? Thank you.
We can go after if you want. We can talk about it after. Okay, so this one I'm just going to give you a hint. Maybe let's try centered interval. Again, the other class we were trying both just to see. I think we kind of ended up with, centered is a little bit easier just in terms of the calculations. But they should both work. And then again, on evaluation, we might just give you a hint and say, or not hint, but we use centered interval, just so you don't have to hem and haw about, I don't know which one would be better and stuff. So we might do that.
How could you tell which one would be better to use?
It's not really better or not. It's just that this one they were like, it seems like a little bit more work because I had to simplify. I couldn't simplify, and then I have to sub in, and you're just getting your two M1 and M2, so it'll work either way. But then we went, okay, that one seems a little bit more straightforward, so that's why, right? And both ways will work, right? So it's not too much more work. So if we don't tell you, then we figured, it's about the same. Okay, but they will both work. So here, let's just do one. Okay, so the centered interval will be M equals, and again, I'm going to start it over here, and then I'll compare the points. So M equals F at, and we've got -3, so -3.01, and minus F at -2.99. And this will be -3.01 minus -2.99. Okay, and then we're just going to sub it in. So we're going to get here, so it'll be 4 sine 5 times -3.01 minus 4 sine 5 times -2.99 all over -0.02. Okay, and then we're just going to keep working with that. I would maybe do the number first. What do you think? 5 times. I punched everything into a calculator, but I'm kind of weird like that. So this here, if you want to simplify a bit more, you can go 4 sine -15.05, right? Minus 4 sine 5 times 2.99, -14.95. Stop me if I've got the numbers wrong. Just did it rough over here. And then you get your two values here. So when I got this first one, 4 sine -15.05, I got negative, and then we weren't sure what decimal, so let's do 4. Okay, so -1.038. Let's do 4. So I think that worked. We were testing it out. Minus 4 times sine -14.5 minus -1.0319. Right, let's try 4. And then -0.02. So when I did that, so I got my two values here, right? So we know again, so if you keep it nice and organized, F at -3.0 is this one here, and we keep it there. Okay, and then minus here, that's this one. Right, we kind of kept it separate, yep. Oh yeah, right here? Yes, thank you, yep. good. Approximate, because I rounded off there. Thank you, yes. And then we tried it, so negative 1.0386. 2, and we got, or I'm getting, so I didn't round it again, I kept that, and I'm going to go 0.335. And I purposely chose this one because sometimes students go, is that close enough to 0? Should I round to 0? Because technically it approximates to 0, and you're like, oh crap, I don't know, is it 0 or not? So that's why I purposely chose this one. I was like, okay, this one should be confusing. If it's like 2, 3, 1, you go, no, it's not, we're done. This is a bit confusing because you're like, it's kind of 0, but it's not quite 0, so what does that mean? So then keep going with the question and see if the rest of the question will kind of clear it up. So when it's vague like this, so sometimes I use a slope and it's like negative 14. Yeah, definitely not a maximum. But if you kind of get this, you go, if it's 0, but it's sort of almost 0, but it's not quite, I don't know what to do. So then what I want you to do is keep going with the question so you can do it, like maybe see if there's a bit more information and do a proper decision in a second. So here, I'll show you what the next step looks like if we try to finish it and go, I don't know what to say. So keep going, and we're going to say, then I know that the point, so we know that F, so compare the points. So compare the points, and we're going to go F at negative 3.01 equals, and we got that here, right? Negative 1.0386. Then we have F at negative 2.99, and I grabbed that from over here. It's negative 1.0319. And compare that to F at negative 3. So plug in F at negative 3, which I don't have here, right? I don't have it there, so I need to plug that in. Did I have it in the question? No, I don't. So that would be 4 sine 5 times negative 3. So it's 4 sine of negative 15. And that would get me 4 sine negative. And it's approximately negative 1.0353. And then, if it helps you, draw a little something for yourself, right? I tried it on Desmos just to make sure I had a weird number for you. And again, this is why I chose this question, because it was kind of like, what do I do with that? It's sort of 0, but not quite. So then, again, you don't have to show this, but if you're like, okay, I want to just picture what it looks like, draw a little something for yourself and go, okay. So then if I was graphing this, this is going to be just the 2 points. So it's going to be negative 3. So at negative 3, I have negative 1.0353, right? So I'll just put it there. So that's this point. Then my blue point here, that's negative 0.353, negative 0.319. Is that higher or lower than 0.353? The decimals. Is that more or less? So think of it like money. 0.353 is more negative than this one. So this point here at negative 2.99 is a bit above. Right, a little bit above there, 0.319, 0.353. That's more negative, it's further down. Then this little red one here, 0.386. This is 0.353, that's 0.319. 0.386 is actually more negative, it's down here. So is that a max or a min? It's definitely neither. Does that make sense? Because this one is in the middle. So it's like, no, it is definitely not a max or min. And if you look at Desmos, I did the graph, and it ends up being something like this, right? So slope, it's sine, and it's somewhere over here. Like it's in between. It's definitely not a max or min. Because I was like, was trying to look for a weird number, and it's definitely not a max or min. It's somewhere in between. Again, this is exaggerated just so you can see where the y value is. But it's confirming the fact that you were like, that's not exactly 0. Like that's not quite. And I don't think it's a max min, and you go, wait, it's definitely not, because look, my y values don't even match for max min. Yes?
If the points are both above or both below, then would you say it's a max or min?
Yeah, you would be like, yeah, I think it is, because we're really as close as possible to either side. And that's why, because these are so close. If you're like here and here and you're right beside the point, then yes, it's a max min.
Like, what if it was at 0.5 or 0.6? How far do you go?
Yeah. Oh, no, you would,
Like for the on the left, the slope.
oh, you
Here
want to
it's
go as
0.3.
close as possible. Yeah, you
I
want
mean,
to.
like here it's 0.3, so you're saying that's close to 0. Like, how close to 0 can it be? And you still say it's
It
not.
should be closer. It honestly should have been like 0, 0, 0, and then you know it is. This is really pretty far away, honestly. That should not be rounded to 0, but I do get the students who, that's why I was like, when you get something like that, and you want to make a decision, maybe check the point, and then you go, yeah, I was right. So you shouldn't be rounding on it. It should be more like 0.00000, 4 zeros or something like that, and then you're like, yeah, it's 0. It's so close.
Best if you get that, can you just say it's not a max or min?
Yeah,
You don't have to
yeah,
go further.
yeah, that one should be fine. Okay, but if you're not sure, then keep going. Yeah, because again, some people round too fast and stuff, or they make a calculation error. You're like, I'm not sure. Yeah, but that should not be zeroed anyway, because it's not 0. Shouldn't be rounded to 0. But yeah, I usually get students who are like, that's pretty close, and if I round, it rounds to 0. I'm like, it's not really, and also just double check the points. Right? If we say something like confirm with comparison of the point, then that just means we want to make sure that you confirmed as well. Right? Because that also confirms it. So whether or not that was max or min, these points here are going to confirm the fact that it's not a max or min. So this is basically just an extra confirmation. Right? Yeah. Right? So if you have any other slope and you check it, it's not going to be. Yeah. Okay? So that's why. So I wanted to show that one, a little bit interesting. I'm going to give you guys a bit of time. Try this one. Right, and then we'll take that one up, and we can decide which method we wanted to use, etc., and we can try that one. All right.